Hello everyone. Thanks for joining. We can start with this session. Today we are starting with Oracle database. So today's agenda is Oracle database fundamentals and database architecture. To start with this session, we'll first understand what is the need for database and how the databases are getting used in day-to-day life. And then we'll try to understand Oracle DBS day-to-day activities. And finally, we'll proceed with the database architecture part. So this particular session will be divided into two parts where first half we are going to discuss about database fundamentals and later we'll be understanding the database architecture. To start with this, first of all, we'll try to understand what is Oracle database. So when the term database come into picture, that means you are collecting large amount of data. Okay. So Oracle database has been invented in year 1979. So the idea of creating this database was like, let's say we have a large set of data. So at the beginning phase, this wasn't like we're talking about millions of records. At that time, we have very small data sets that we wanted to put at one place. And whenever it is required, we can fetch those information. So on the basis of the same, we have one of the uh, database that was created by a person named Lawrence Ellison, mainly from the Oracle Corporation. He has developed this particular product called Oracle Database, and it is based on RDBMS fundamentals. That means it's based on the Relational Database Management Framework. So when we say like RDBMS, what is the significance of RDBMS? First, we'll try to understand that part, and then we can talk more about this one. So RDBMS basically is like a related data. So let's say if we have one Excel sheet, okay, this is like a very basic level we are talking about right now. So suppose we want to store two different uh, data. So one data can be, let's say, a customer specific information. So when you define any tables, you have to define the columns, right? So that column can be, let's say, customer ID or customer name, contact number. Now there's another table. So another table name is order. And this table, we have some of the columns like customer ID or order ID, order date. So when we require some information related to the customer, so what we can do, we can refer this information from the customer table. Okay. Basically, we are talking from the application point of view, like how application get designed. So suppose there is a one application which stores the customer information or ID, order ID information. So internally there's a tables that stores these data. So one of the table can be a customer table, another table can be an order tables. So whenever we require some information to be pulled in the order tables, I can refer the customer ID, which is like a primary key. So there's a relation between these two data. Okay. So when we are talking about related data, that is basically a RDBMS database management system. Now again in RDBMS system, whatever the data we have, they will be in the structure format. Okay. When I say structure format means, let's say a table with customer. Okay, so this table will have customer ID, customer name, and contact number. So whatever data that we'll be putting in these tables, they will be always in the structure format. Like while you are defining a tables, you will be mentioning like what will be the customer ID value or customer name or contact number, right? So either customer ID will be like, let's say 5-digit numbers, right? So we cannot go beyond that numbers. Definitely we can restructure whenever it is required, but while we are defining a particular table, that table will always have a specific structuring system. Similarly, let's say we are talking about customer name, so we'll define like maximum customer name characters can be 50 character or 100 characters, like that. Same goes for contact number. So contact number will be either 10 digit or 12 digit of numbering system. So whatever data we are putting in these tables, they will be always in the structure format. So while we create any tables, we have to define the columns. So column names can be this, and against each columns there will be a specific set of data will be there, that is called as a record. So this data record means it's a row, and the column means what do you call fields. So combination of rows and column basically makes a RDBMS, or you can say RDBMS tables. So the combination of multiple tables is basically your database. So in within the database, we can have other objects as well, like we can have indexes, or we can have procedures, functions, triggers. So all the like dependent objects can be present within the database. And mainly the RDBMS database is designed in such a way that we can store the data, we can retrieve the data whenever it is required. Now, what is the benefit of having Oracle database instead of other database? So in market, we have almost multiple databases, and Oracle database, I'll say like they are uh, number one since the beginning itself. Okay. And almost like 40 years or 50 years that has been since the product has been launched, still they are in the market. With every day they are improving with certain new features. So Oracle database supports scalability, high availability, as well as it also supports database security features. Performance is another benchmark that they always set. Okay. So looking at all these different features, basically Oracle database is still a very good product to use for an industry data management system. And so basically Oracle database can be defined in two different structuring system. You can say a logical structure and physical structure. We are going to discuss more on this maybe in the database architecture part. So as of now, I'll just give a brief information about it. So let's say if we create any database, there are multiple table spaces get created. So here the table space means it's like a small container that will hold the data. But if you look at the database level, these containers will be actually referring to a data files. So when you create any database, it will have multiple table spaces. So that table space is called as a logical structure. Means logically you have given a name like this is my one of the table which will store the user's data. Then another, so each of the table space will have related data files. So relationship between the logical and physical structures makes the Oracle database as a complete entity. We can look into some of the practical about this. I mean, let me connect to one of the database, then we can go more detail on this. Just 1 second, guys. Some network related changes I need to make. All right. So this is one of the system where the database is already present. So I'll try to explain how table space or data files are related to each other and how they are basically considered the logical and physical structure of the database. So whenever we create any database, there are like five different table spaces that get created by default. Okay, so table space is nothing but a container which will hold the data. So whatever tables we are going to create, by default, they will go inside the table space. Okay, so select table space name. So here we can see like we have total four main table spaces. The temporary table space we can fetch is from the different table space. So overall we have total 5 table spaces. That means when I created this database, the database name is ORCL database. Okay, this database contains 5 different table space. As of now, we can see 4 here. One more table space is that is called as a temp table space. Now against each of the table space, you will find out there is a data files present. That means this data file will be present at OS level. Okay, like at the mount point level, these files will be present. So that means under U02, you will find one of the data file available here. That means this particular file is actually containing the data. Maybe this is a system related data, or there can be another data file that holds the user's information. So whenever we create any users on this database, and that user will be creating a table, so their data will go inside this particular file. So these are called as a file data files, and this is called as a table space. So here system, sysocs, undo, or users, these are the logical structure. We have just given a name. Against these files, I mean these table spaces, we will have the actual files. Okay, so this is called as a physical structure. So logically means we have just defined the name. Physically means it's already present at server level. Okay, so that's what basically the Oracle database is formed with the logical and physical structure. We can look more detail about it when we proceed with the architecture part of the database. Along with this, database can be all these is accomplished with the help of high performance. A database server also prevents unauthorized access. So as I mentioned, like Oracle database supports database security features, and in fact, we can create and manage the users. We can allow, let's say, a specific user to access the data. So whenever you create any new user in the database, we have to first grant the access to the database. Like there's a privilege called create session privilege we have to assign. Along with this, let's say a user wants to create a table in the database, they have to have the create table privilege. So whatever operation the user is trying to make within the database, that requires the privileges. Without privilege, nothing can be done within the database. So overall, the benefit of database that we are trying to understand here. And along with this, a database basically, a database server is a key for solving the problems of information management. So the Oracle database basically can be used for various range of data management purpose. Like for example, it can handle the online transaction related data, or it can be used for storing the retail specific data, or it can be also used for like banking customers. So different environments like finance and organizations we can have, and we can store those data into the database. So it's like a complete solution for industry's requirement. And then uh, we can discuss more on relation database management system. So when I say like Oracle database, it's basically a relational database management system. Ultimately, it's just a combination of multiple tables that is available within the database, and which is known as a relations. And now a table is basically a combination of rows and columns. So when we create any new table, we define certain columns. For example, if you look at the previous two examples, like let's say I'm creating a customer table, so we need to define the various column within this, right? Customer ID, customer name, or customer contact number. So this way we can have multiple columns. So when you will be working in production environment, you'll find like within a single table, there will be like 15 to 20 different columns will be available. So mainly one of the column will be treated as a primary key. So primary key is mainly for uniquely identification of data set. So for example, there can be multiple customer with a similar naming conventions. So for each customer, we can give a customer ID so that we can identify this customer is XYZ, and so on, right? So there's always we have to define a primary key for a tables. That way you can identify the data sets easily. And then additionally, we have other columns also that will store the information related to the subject. So now to manage the relationship database system, we have a structured query language, which is known as a SQL queries. So later, when we start with the practical session, we'll be exploring SQL query language, where we are going to learn about how to create new tables, and then how to insert the data within the table, then how to retrieve the data, deletion of modification. So there are like two sets of two main categories within the structured query language, which is known as a DDL and DML, data definition language and data manipulation language. Okay, so in order to manage relational database management system, ultimately we are talking about Oracle database, and in market we have other databases as well, like SQL Server or MySQL database is another one of the product. So Basically, to manage a relational database management system, we are using a structured query language, and these are some of the possible scenarios, like you can create, delete, modify data within the database. In fact, we can select, insert, delete, and modify the data of the tables. Now, what are the use cases for databases? So as I mentioned, like there can be a two different categories of the data uses, or it can be a combination of both of them. So the first category of data uses will be it can be an online transaction processing. So when we say OLTP, means it can be most of the time it can be like you can say a time bounded data processing. So within the database, let's say take an example of any e-commerce website, or maybe an ATM withdrawal system where we do some transactions. So whatever the changes are happening within the database, it has to be done within a limited time of timings. Okay, let's say within 5 seconds, or maybe within 1 minute of time frame, everything has to be completed. If it doesn't complete, that means that transaction might fail. Okay, so transaction means what? So when you make some changes, so it has to be get committed. Okay, like it has to be permanently saved within that tables. So suppose if we are talking about a table with online transaction processing system, so when we do some transaction, that means we are creating some order ID, right? So if you take this particular example, let's say one customer has logged into the particular portal and he is making some transactions. So once he make the transaction, there's order ID get created. That means these tables internally get updated, and whatever the data changes has been done, that will be committed also. That means that will be permanently saved within these tables. So this entire operation has to be done within a limited time frame. So when we are having a transaction processing within a given time frame, that is treated as a OLTP database. Now, opposite to this one, there can be a situation where we are looking at the data, but here there's no limitation on the timings. That means we are trying to select large amount of data, and we are not bothering about the timing of data selection. Okay, so this kind of data is known as a data warehouse workload. So there can be a situation like, let's say, take an example of any application like Facebook or some of the other application where they analyze our data patterns, like whatever we are nowadays, whatever we do on online. I mean, let's say we visited particular link, or we are looking at particular subject. So accordingly, they will have all these data set in the backend. They will analyze the user behavior, and then accordingly they will try to generate some new data sets. So when we are having a large amount of data, and based on that, using the complex query, we are trying to access the results. That kind of data category comes under the data warehousing workload. Okay, so basically the idea here is like Oracle database can serve these kind of different data sets. Like it can be used for OLTP transactions, or it can be used for data warehousing system, or in fact it can be used in the mixed environment, like a database can be used for both the purposes. So mainly in production environment, if we have defined a database for OLTP transaction, I mean that will be dedicated for that particular operation. So there are, like when you will be working in production, you'll find like there's like archival databases are there, where large amount of or the historical data is present, that is mainly used for data warehousing. Okay, so there the developers will try to write a complex query, and they will try to fetch the particular patterns. So and there can be a situation like within the same database, we are trying to run the OLTP transaction as well as data warehousing. But again, this kind of database is not good for any organization, because let's say we are trying to do OLTP transaction parallelly. There is some users are running a long running queries within the database. Ultimately, it will consume the system resources, and your OLTP transaction might get impacted. So that's the idea. Basically, we should not use single database for both the workload patterns. Maybe we can use multiple subset databases, and accordingly we can manage both workloads. Okay. So this is about Oracle database uses. Now we'll talk about the different versions of Oracle databases that is available so far in the market. So I mean, since last 10 years and I will say like 12 years, these are some of the main databases that we have in the markets. So 11G relates to 12C version, then we have 18C, 19C, 21, and now we recently there's a new version 23 AI has been launched. So these last two databases like 21C is like a evaluation version, so it will be anyways it is not a very long-term supported version. The long-term supported version is 19C, which will remain in market till year 2027 in the extended support. So when I say support means if suppose there's some problem happens within these databases, database versions, basically you can raise a service request with Oracle and they will provide you the solution. Along with the solution, they will also provide you the patches for the database. Okay. So 19C, anyways, it's a stable version for still for next 3 to 4 years in the markets. Now 23 AI database version, it has been just launched for developers. In fact, you can also try, but still that is not like fully installation version is not available. So far, it's just a initial phase. So overall, like these are some of the major database release that has been done. Now, if you are looking at the feature of each of the database, I'll give this link in the Wikipedia you can go through. There is hardly any major differences, but yes, like it's like a mobile phone that get launched with every years like different. Some additional new feature definitely will be there. Let's say we are talking about 19C. So when the 19C database was launched, so we have a feature called auto indexing. That means based on the query patterns, there's an automatic indexing can be done. In fact, there's another feature called query quarantine. So if particular query is causing a lot of problem within the database, we can quarantine that SQL ID. Okay. So similarly now in 23 AI, we have vector search. It means within the database, you can search any kind of, data we have data. So the data has to be there within the database, and you can try to run any kind of different complex queries that you can. So that way, for every database, we have a new features available, but the core fundamentals of the database will remain the same. Like it will be used for performing the DDL or DML operations. So when I started working on Oracle database, I started learning from the Oracle 9 version. Now, so far, we are on 23 AI version. So it's a long journey for me, at least. So yeah, this is like this is how these are the timelines when the database software has been. Mostly, you'll find the year in which the software is get released, and based on that, they have given this numbering system. So more information you can get it from the link given here. Now, next point is regarding the database administrator's duty. Like so far, we have understood like what is the uses of Oracle database and what is Oracle database itself. Now we'll look at the our responsibility. Like while we are working on Oracle database platform, what we have to do and what are our day-to-day activities. So it's basically again there's a possibility like you will be doing the installation of Oracle software. This is not a regular activity, but yeah, it's like a one-time process. You'll be do so within a years, maybe 1 or 2 times you have to do the installation configuration. If you're working for let's say implementation project where the a new environment is supposed to be created, like that time you have to do the multiple installation also. And then once you install the software, you have to create the database. Along with this, now in the middle of this, you will find out database administrative task like regular activities. So some of the time, you say if there's a maintenance activities happening, so at that time you have to shut down the database, start with the database. Okay. Along with this, we have to manage the storage structure. So when I say storage structure, means this data file management system. Okay. Like for example, in this database, we have default table spaces. So each table space contains minimum one data files. Data file is basically it has a limited capacity. So this data file can accumulate up to 32 GB of data. That means if I want to store some data within this data files, it can go up to 32 GB. So what will happen when the 32 GB of the file is utilized? So we need to add one more data file in this table space. So one single table space can have multiple data files associated with it. Same goes for users table space or any other table spaces. Now, while you'll be working in a production environment, you have to regularly check the specific table space. If it goes beyond, let's say, 90% utilization, then you have to add one more addition. So now, previously we used to do all these monitorings manually. But now we have a OEM monitoring tool that is called Oracle Enterprise Management System. There you can schedule the particular jobs that will keep on monitoring the database health, and whenever there's like a data files reaches to a particular threshold value, it will trigger email notification. So anyways, those things we are going to learn how to schedule the notifications to get alerted about the particular table space utilization. Okay, so yeah. So we basically have to manage those structuring system. There might be a situation, let's say there's new application is about to deploy, and while the application deployment is happening, we need to create one table space, maybe one or two table spaces, and then within that table space we have to add sufficient space. So all those things comes under this, and then managing the users and security. So we have to create a users, and then for that user we need to define the privileges. So all those things comes under this managing the users and security. So there might be the situation, let's say a user's account has been logged due to the wrong password attempt. So again, and that thing we have to manage manually, like we have to unlock the user's account and so on. Or there can be a situation, let's say a user is no longer working with the organization, we have to delete the user's accounts within the database. So all those things we have to handle here. And then along with this schema object. So schema object means the tables or the indexes or the views, and there can be other objects as well, like there's something called triggers, functions. So all these combinations, we have to create those objects within the database. So mainly these activities something done by the application developers, but maybe sometime it is possible that the query will be shared by the application developers. We just have to execute it. But before executing any such queries, we should understand like how the query has been written. So it is our responsibility, like we should know how the table creation can be done or index can be done, what can go wrong in these particular commands. So all those things we should know while managing the database. Along with this, the most important point is backup and recovery. So backup is like for because we are talking about critical data sets here. So whenever there's some issue happens, like, so we should have backup copy available. Now, in order to have the backup copy available, we should regularly take the database backup. So in Oracle database, we have two different tools that can be used for taking the backups. We are going to discuss in detail in while we are discussing the architecture, but I'll give the quick information on this. So we have something called RMAN, which is known as a recovery manager. And then we have a EXPDP, that is an export data pump utility. That is to take the export, and for import, we have IMPDP. So using these tools, we can take the backup of database, or maybe we can take the backup of a specific set of data. Let's say I'm talking about a table level backup or the user level backups. So those things can be achieved with the help of EXPDP utility. Now, do we need to do the recovery every time? So answer is no, until unless there's some problem within the database, or maybe let's say we are taking the backup from one server and restoring it on another servers. So in those scenarios, we have to do all this activity. Otherwise, generally we take the backups, we keep on monitoring the backups completion status. Like sometimes there might be the situation due to less space available at backup mount points, backup got failed, right? So in those situations, we have to basically look into the logs whether the backup has been completed. So while you'll be while you'll be working for a production system, you have to regularly check whether the backup is getting completed. Obviously, you can schedule the email notification via the OEM utility that will generate a report and will send the status like the backup is completed. If in case it is not completed, then you have to manually intervene and take the necessary, provide the necessary solution and fix the problem related to the backups. Along with this, we have to also proactively check the database health and take the necessary action. So when I say proactive database health checkup, basically it's like looking at the database overall. You can say like database alert logs, and then also you need to check the table space related information, like whether we have sufficient space available, or how fast the table spaces are getting filled within the database. So all those information we have to pull from the database health check reports, and then based on that we can take the necessary action. So sometimes it is possible like there are some issues within the database and we are not checking, and there's no alarm has been raised so far, but there's a possibility like, because of this particular issue, our database might struggle for some time. Okay, so if you have done the proactive health checkup, definitely you could have identified the problem and taken the necessary action. So while you'll be working in production environment or any environments, like I will say like 60 to 70% of your job will be monitoring, and 30% of the task will be the remaining task. Like maybe you have sometime you have to create users or manage the space. So monitoring is very critical and critical and important section while working as a DBA. Okay. Along with this, you can also do a regular database health checkup, like the active session information. Like let's say in one of the databases, generally we have 20 to 30 active sessions, but at one day we are seeing like suddenly the active session has been 100 or 150. Okay, so whenever this kind of situation arises, if you have done the monitoring of the database previously, obviously you can relate like, yeah, my database is running with high number of sessions, and take the necessary action to reduce a particular problem. So overall, like these are some of the things. Along with this, while you're working for a production environment, we have to regularly perform the database patching, apply the security features within the database, and then whenever it is required, we have to do the database upgradation. So generally, the database upgradation is like a major activity within the database, and it happens once we have a new release of the database. Like for example, in recent time, while if you have worked for a new organization, you have seen like most of the databases from 11C or 12C that has been upgraded to 19C. At least last 2 years, this was a major activity. Now, if you look at coming years, like let's say for next 1 or 2 years, you'll be finding like most of the organization is going to migrate their databases from 19C or 21C to 23 AI. Okay, so this upgradation is again is a very important activity. Generally, it is something done by a senior database administrator within organizations. It's like a detailed plan activity that we have to do. First, we need to identify existing systems, and we need to do a proactive patching on the existing databases, and then we have to do the testing of upgradation in the lower environments. And then later, once everything is looking okay, then we can go ahead with the production upgradation. Okay, and then along with this, we have performance tuning related stuff. So if your database is running with optimal performance, that means and database is doing its job properly. Otherwise, if suppose take an example of an OLTP environment, suppose one transaction is supposed to complete within let's say 1 minute or 30 seconds, and if it is taking more than 2 minutes, that means all the transaction will be declined, right? So our job is to tune the database in such a way that the performance of the database is always optimal. So whatever queries are getting executed, that will be getting completed within a specified time frame. So we can look at the database health check. We can identify which are the top queries within the database, and overall server level performance also we need to check with the help of, let's say, top query and then free commands or VM stats. So when we analyze these different data sets, we can pinpoint like this is the problematic area, and we can let's say tune the SQL queries, or maybe we can uh, scale up the particular database server in terms of system resources, or if the, let's say a particular IO device is slow, then we can suggest like we should have a better IO devices for good performance of the system. So all these stuffs comes under the performance tuning. So while you will be working for production environments, you have to regularly look into the performance section of the database, because at any given point of time, you might come across a situation like application users are complaining like the queries performance is slow. So when this particular term comes, query performance is slow, then you have to think from multiple angles, like why the query is getting slow, since when it is getting slow, any changes has been done to the system, and then you'll start looking into the various areas within the database, and accordingly you can suggest like this is the solution for the problem. Okay. Anyways, we are going to talk more in detail about all these steps. I'm just trying to explain like what are the responsibility of database administrator, uh, at least from the fundamental point of view. So this is about the responsibilities given by to a particular DBS. So for any organization, we'll find minimum like one DBS will be available. If there is a large number of databases to be handled, definitely there will be a set of DBS. Now within the database, within the set of DBS, there can be a different categories of the DBS. So let's say one set of DBS, maybe one or two guys are handling the backup and recovery related stuff. Few are only doing the patching, and few are doing the troubleshooting. Okay, and there can be a categories of DBA who is only doing the monitoring of the database. So in some organization where less number of databases are available, there we are only talking from the, so one or two DBS is handling all these different areas. Okay, so everything will be done by those one or two DBS who is part of the team. If we have a large database to manage, definitely each stakeholder will have a different responsibilities. So far, I mean, whatever we have discussed here, this is like one of the high level, and along with this, you can also have high availability related stuffs. Like we have to monitor the standby database. We need to configure, create the standby databases. We need to regularly check whether the standby is in sync or no. Okay. So yeah, these are some of the activities we have to do. Any question, guys, so far, like whatever we discussed, so are related to the relational database management system, or related to whatever we discussed in this particular slide? Any questions?
Yes, yes, I just into the chat. I want to know what is in my AR where you actually mentioned that a version of the database, and in 23 I saw that there is a AI mentioned.
So
So what is in
basically,
the AI?
AI means it's a artificial intelligence based database. Okay, means now everywhere you are seeing like AI is one of the a new skill set that has been available in the market. So now Oracle has also implemented some of the AI based features within the database. So one of the thing is like, let's say we have some data available within the database, and we are trying to
Mm,
access the information from there. So that data is already part of database. So we can, I mean, just type, let's say I want a particular specific data from within the data. So it's like we are giving some additional AI based features like within the database. Whatever the data is there, we can fetch in different ways. Okay, you can type the queries in different ways to fetch the data. Is known as a vector search. So AI stands for artificial intelligence in this particular version of the database. And along with this, you have asked regarding the OEM, it requires separate license. Yes, OEM is a licensed product, so it will be required, right? But for our learning purpose, it doesn't require anything as such.
okay. Regarding AI only, it's artificial intelligence. I understand that, but does it put means impact on the DBA life? That is, it's automated or something else like that.
Obviously, I mean, when we are talking about artificial intelligence, definitely it is going to impact, I mean, DBS job as well, because some of the things that can be very easily automated. Okay, and let's say we are talking about, let's say, table space management, or monitoring of the database health, and proactive monitoring. So all those things can be very easily managed well within the database without any DBS intervention. Okay, for example, like in 19C, we have this new feature was implemented like auto indexing. Okay, though initially
Mhm.
this feature was not very useful, but now if you look at in 23 AI, I mean, they are going to hardly they will be basically pushing towards this particular feature, because most of the time when we are troubleshooting a query performances, you'll find like if the table has the indexes, it will definitely give the better performance or better results. Queries performance can be improved. So such features they will definitely push, and with the help of this AI based features, so it will automatically understand the behavior of the queries, and accordingly it will take the necessary actions. So at that point, you'll find like the performance tuning section is now no longer in the DBS hand. It is something database itself is doing all this checklist, and it is taking the necessary action to improve the performance of the query, right? So a decision making system has been developed, at least from DBA side, database side, and it will take the self decision and take the necessary action wherever it is needed.
Okay,
So that is
great.
like one of the things. I mean, if you're looking at the complete detail about 23 AI, definitely that is something we can discuss maybe later as well, because it's just I haven't gone through the complete documentation of this 23 AI version. But
Okay, no problem.
whatever I have learned so far, I mean, based on my understanding, this is how the new feature will be implemented. So within the database. So yeah.
Great, great. Thanks for this.
Any other question, guys? So along with this particular option, let's say in between we talked about different table spaces. So when we define any database, this is how the layout of the database will look like. So will have a database as a complete container, and this database will have multiple table spaces. So table space list is like system table space is SOX table space. So these two table space mainly used for dictionary objects. So when I say dictionary object means, when you define the Oracle database, there are different sets of tables that get created. And this table is basically a dictionary table, means it holds the information of other tables or the objects within the database. Suppose if I create some users, let's say user test one I created within the database, and that user has created a table employee or salary table. So this table's information, like what is the number of columns, or how many record this table contains. So this information is basically stored in the dictionary tables. So every data is related here, means whatever the information of employee table is, like how many record it contains, what is the maximum value, minimum value, or how many columns are there in these tables. So all those information is stored in the dictionary tables. Now, while processing the data, there might be some of the situation it requires some additional information, like what is the statistics of these tables. So all those information will be available. How many indexes that has been created to these tables. So again, that information will be available in the dictionary table space. So system and SysOps table space mainly used for keeping those information. Okay, and these are the by default they will be part of the database creation. So when you create any database, these two has to be there. Along with this, we have a temporary table space. So generally, the temporary table space, the name itself suggests it is used for temporary data processing. Means, let's say I'm performing some select statement with order by clause. Order by clause means we are trying to sort that operation data. So suppose we have a table with, let's say 10,000 records, and in this 10,000 records, all these data are ascending or descending orders. We are trying to fetch the data in, let's say, ascending orders. Okay, so obviously we have to do all this sorting operation. So that sorting operation can be done in this temporary table space. Along with this, there's a situation might we have to rebuild the indexes. So rebuilding of index means restructuring of the complete indexes, because index is basically for a data reference. Like let's say one table contains different data. There might be the situation few of the records within the table has been deleted. So subsequently the indexes has to be also get adjusted. Okay, so when we do index rebuild, all these data which has been deleted, the references will be also deleted from the indexes. Okay, so that makes the index performance better. And when we do the index rebuilding, basically it requires a temporary table space. So a temporary table space can be used for multiple purposes for a temporary operation within the database. So system, sysocs, and temp tablespace. These are some of the important tablespace. Along with this, we have undo tablespace. So undo tablespace main significance is that, let's say I'm trying to modify a particular record in the table. So while we are trying to modify the record, what was the previous value? Okay, like last image of that particular data that we are trying to modify, that will be stored in the undo table space. As the name itself suggests, undo means we can go back to the undo that whatever the data change we have done with the help of this undo table space data. So there's a retention policy that we have to define. Let's say for by default we have 15 minutes of data that we can retain in the undo table space. So if suppose a user is trying to modify a data, so what was the previous value of the data modified data will be available in the undo table space. For how long it will be available? For 15 minutes by default. If we have changed the undo retention time, definitely we can have large, previous available data for based on the retention time. So this information will be available in the undo table space. Along with this, we have users table space. So in users table space, generally we keep the user data. Suppose I'm creating a new user, let's say test user, or any, let's say a customer table, customer specific users, or maybe application based users we are creating in this table spaces. So their info, whatever the tables that particular user will create. So this data will be available in this particular table space. Now, each of the table space, they will be having a data files mapped like this. This data file are the actually that is holding the data for that particular users. So suppose if I create a user test one, and that user will have two different, what do you call this one? Two different tables like employee or salary. So these two tables data will be ultimately it will be present in that particular data file. So in this case, it will be users data file. So where is the user data file? It is available inside the U02 mount points. Now suppose because by default these table space have one data files available. So once the first data file is filled, then we can add one more data file. Like that, you can add a multiple data file within the single table space. So to handle this operation within the database, we have a DTL and DML that are the two main structure query language that can be used. So DDL for data definition means you can create tables, you can drop table, alter tables, and DML means you can basically make the changes within the data. Like you can run the select, insert, update, or delete queries. Select will not be here. It's a insert, update, and delete. That are the main point. So this is how the table spaces are related within the database, and each of the table space will have a direct mapping against the data files. Now, while we are going to discuss about Oracle database, there are another terminology that is called as a container-based database and non-container database. So container-based database means it's a multi-tenant architecture where we have multiple pluggable database. In non-container database, what happens? Like within a single server, you have one database that we have defined. And in this database, you will have the separate table spaces like systems, socks, undo, and users table spaces will be available. And in that, all this data will be basically stored. Now, when we are talking about container-based database, here you can basically create a subset of databases. Let's say for organization, there are different departments are there. So based on the department, we can create a pluggable database. So what is the benefit of creating this way of database? Basically, the data management is simpler in this case because now we have divided the entire data in different subsets. Let's say at one given point in time, we want to move this data to another server. So what you can do, there's a feature called unplugging and plugin. So first you will unplug this database from this existing container and move it to another database server, and there you can plug it back. Okay, so here database management is very simple, and also it saves the resources. So suppose if you have to create a multiple databases like let's say PDB1, PDB2 at different servers, definitely it will require the resources. So we require multiple servers, we require multiple hardwares. But here in this case, if we are keeping all the data within a single database container, when we are using a limited resources, the management of this data is very simple because we have a feature of unplug and plug. Along with this, a database administrator just have to connect to only one individual server rather than connecting to multiple servers, right? So now if you look at the Oracle database 21C onwards, we are going to talk about the multi-tenant architecture only. Okay, so we should know like how to manage the databases in multi-tenant architecture, how to create this pluggable database, plug unplug, or how to create this container database, and how to connect to each of the PDBs. So all those things we should know, how to take the backup of each of this. So in our syllabus, we are going to cover everything based on the multi-tenant architecture. So if you know this particular database management system, obviously you know how to do the non-container database as well, because the logic will remain the same. Here we are talking about individual servers. Here we are talking about multiple databases, like subset of databases. Okay. So this is like how the container and non-container database will be created. Let me see if I have already connected to this database. Yeah, so this is an example of this database. Yeah, so there's a question, what is a plug and unplug? So basically unplug means what you can do, you can first, you have to shut down the database. Let's say we are talking about one of the database name PDB. So you need to first shut down this database from here. You have to drop this database. While you are dropping the database, I mean, you will not drop the data file. Okay. So basically you are removing the reference of this database from this particular database, and then you will be moving that data files associated with this pluggable database along with the there's something called structuring of, or you can say one XML file is there which hold the information of this PDB. Okay, so it's a definition of the particular table space will be available in that XML file. The so XML file along with data files, we have to move it to the other server. So when you remove the database from here, that is called as an unplug, and when you insert this database into another database, that is called as a plug. So obviously, while doing the unplugging, we have to shut down the database. So when you shut down the pluggable database, it get mounted. It's not like it will be completely down. It will be mounted, means no one can access the database. When it is unplugged, and then later you can move this data to another server, or maybe within the same server, if there is another database running as a multi-tenant architecture, there we can plug it and we can utilize the database in within that particular database. So this is one of the example where we are already connected this database name of ORCL database. So when you define any container based database, there is a by default layout or the structure that get created, and this is the read only database. It's known as a seed PDB. Okay, so here PDB is pluggable database. This is a seed PDB, means it just contains the layout. Okay, so suppose if I want to create another pluggable database, so I'll be using this particular option or this particular pluggable database as a reference. So this particular seed PDB will have its own system sysocks or undo table spaces, and based on that particular table space, the new pluggable database can be created. So suppose if I create another pluggable database named PDB3, so by default its a layout will be